Welcome to Ask and Learn.
So the question reads that 5 moles of an ideal monatomic gas with an initial temperature of 127 degrees Celsius expands, and in the process absorbs 1,500 joules of heat and does 2,100 joules of work. What is the final temperature of the gas? So let's start out by writing out our givens, and then we can discuss which formulas to use. So we have N equals 5 moles, and we have T initial is 120. I'll go ahead and undo that. (127 degrees C), and we know that Q equals 1,500 joules, and we know that work is 2,100 joules, and our goal is to get the final temperature. So first we want to start out with the equation that the internal energy U is equal to, or the change in internal energy is equal to the heat input to the system minus the work done by the system. And we know that the internal energy is always equal to 3/2 NR, I'll go ahead and put delta for change. And then if the number stays the same, that's equal to NR delta T, because generally it's equal to 3/2 NRT. So the change is 3/2 NR delta T. And then we know that 1,500 joules of heat are added. And then we know the work the gas does 2,100 joules of work. And so it looks like we have all the ingredients that we need to solve for the final temperature. So we can say, just algebraically manipulate this and get delta T is 1,500 joules minus 2,100 joules, all divided by 3/2 NR. So I'm kind of mixing using symbols and numbers, but hopefully it's still clear what I'm doing. So if you plug that into a calculator, you got that the delta T is minus 14 degrees C. And so therefore, if you get to get the final temperature, you do your initial minus 14. And if you take the initial temperature of 127 and you subtract 14, then you get 113 degrees C. And then just a note, we didn't have to convert to Kelvin because Kelvin is additive with Celsius. So to get from Kelvin to Celsius, you just add 273. So if you're only worried about temperature differences, you can use Celsius and Kelvin interchangeably. So that's that problem.